November 3rd, 2025. Another one. That's the alert echoing across astronomical networks worldwide. Not another asteroid. Not another stray comet. Another interstellar visitor, designated GB V1 now, later named C25 V1 Borisov, slipping into our solar system in the worst possible place, directly between Earth and 3i Atlas. You pull up the data. No tail, no glowing coma, just a dim, silent object slicing through Virgo, as if it knows exactly where it intends to go. And the discoverer? Gennady Borisov. Yes, that Borisov. The same man who spotted 2i Borisov back in 2019, making him the only person alive to identify two interstellar objects. The statistical odds? 1 in several billion. The implications? Deeply unsettling. Because 3 days later, on November 6th, this newcomer aligns with 3i Atlas and the golden comet K18 less in a geometric configuration so mathematically perfect that calling it coincidence feels intellectually dishonest. 3 visitors, 2 constellations. One question burning through the astronomy world. What exactly are we witnessing? If this pulls you in, subscribe and drop a like when it's earned. Now let's begin. The discovery didn't happen in some pristine observatory with billion-dollar instruments. It came from Crimea, in an amateur setup most professionals would politely call modest. Gennady Borisov was doing what he does every clear night, sweeping the sky with his homemade 0.65 m telescope, the same device that made him famous 6 years earlier. November 3rd began like any routine session. Cold air, dark skies, and the steady click of his camera shutter, capturing frame after frame of the cosmos. Then at 2:47 a.m. local time, something appeared in his data that shouldn't exist. A moving object, faint, nearly invisible against the background stars, yet moving with a velocity that made his software flag it instantly as anomalous. Borisov ran the initial orbital calculations 3 separate times. Each iteration tightened around the same impossible conclusion, a hyperbolic trajectory. Meaning this object wasn't from here. It came from beyond the sun's gravitational reach, travelling at speeds only interstellar visitors achieve. He filed the report with the Minor Planet Center under the placeholder code GBUI0810, a bureaucratic label destined to become one of the most discussed astronomical events of the decade. And then the story turned strange, very strange. When other observatories confirmed the object and captured their own images, they noticed something profoundly unsettling. This interstellar traveller, moving across millions of miles of empty space, had no tail, no coma, no glowing halo of vaporized ice that proclaims, "I'm a comet." Every comet behaves the same way as it nears the sun. Heat rises, volatiles sublimate, and a radiant tail emerges, pointing away from our star like a cosmic windsock. It's basic physics, predictable, universal. But C25 V1 Borisov wasn't, following that script. Dr. Michelle Bannister, planetary astronomer at the University of Canterbury, and an expert on small solar system bodies, said it bluntly in an interview with Nature. We're observing an object that should be shouting across our instruments. Instead, it's whispering. Interstellar comets don't do this. No comets do this at this distance. And she's right. At Borisov's current distance, roughly 0.8 AU from the Sun, closer than Earth's orbit, even the most dormant comets show some sign of activity. Yet image after image from observatories on 3 continents revealed the same thing, a stellar-like point, unchanging, as though made of solid rock rather than icy rubble. 10 observation sessions captured V1 Borisov between November 3rd and November 7th. 8 showed absolutely nothing, just that dim point of light. 2, only 2, revealed something that could generously be called a faint smudge, extending asymmetrically from the nucleus. Not a tail, not even close. More like the ghost of something that wanted to be a tail, but never fully formed. Astronomers compared notes, and confusion deepened. This wasn't error. It wasn't atmospheric distortion. It was an object actively defying our understanding of cometary physics. And then someone noticed the trajectory. Not just where Borisov's object was headed, but where it came from. Backtracking its orbit using precise astrometry produced something that made the temperature drop in every research meeting. C25 V1 Borisov's path, when traced backward through space, came frighteningly close to the trajectory of 3I Atlas. Not intersecting, space is far too vast for collisions without major gravitational help, but aligned. Same corridor through the solar system, same approach angle relative to the ecliptic, same general velocity profile. It was like watching two cars on a highway, one trailing another at distance, both taking the exact same exit ramp. Dr. Paul Chodas, manager of NASA's Center for Near-Earth Object Studies, ran the statistical models himself. He told his team privately before publishing, because in his words, I needed someone else to check my math because this seemed impossible. The probability of two unrelated interstellar objects randomly following such similar trajectories, approximately 1 in 847 million. Those aren't coincidence numbers. Those are something else is happening here numbers. You can almost hear the questions forming across observatories worldwide. Did these objects come from the same stellar system? Are they fragments of a larger parent body that broke apart before entering our solar system? Or, and this is where scientists become extremely careful with their wording, is there some kind of connection we simply don't yet have the framework to understand? The discovery timeline piles on another layer of strangeness. 3I Atlas was first detected on September 24, 2024. It spent over a year closing in on perihelion, giving astronomers ample time to study it, debate its nature, and watch it refuse to behave like a normal comet. No tail, no outgassing, no brightening as it neared the sun. Just a dark, silent object, ignoring every model we have. And now 13 months later, here comes V1 Borisov, displaying the exact same characteristics. It's as if the universe is running the same experiment twice, just to make sure we're paying attention. Gennady Borisov himself remains characteristically understated. When a Sky and Telescope reporter asked what he thought about discovering two interstellar objects in 6 years, he simply replied, "The sky is very big. If you look carefully, you find things." Classic Borisov. But even he admitted in a follow-up email to colleagues that locating V1 Borisov's position relative to 3I Atlas felt wrong, like the universe was playing a joke I didn't understand yet. What makes this discovery go viral, beyond the scientific implications, is the timing. V1 Borisov appeared just as 3I Atlas was dominating astronomical headlines. Social media was already buzzing about Atlas's strange behaviour, its lack of a tail, its unusual reflectivity, its almost artificial trajectory stability. Conspiracy theorists were thrilled. Scientists were cautiously offering increasingly exotic explanations in peer-reviewed papers. The astronomy community was primed, loaded, and waiting for the next twist. And V1 Borisov delivered that twist with surgical precision. It appeared in the worst possible location, right between Earth and the object everyone was already obsessing over, with the exact same anomalous properties that made Atlas so unsettling. It felt like someone had written a screenplay engineered to maximize tension and audience engagement. Except this screenplay was unfolding in real time across millions of miles of actual space, with real objects that don't care about human narratives. The Minor Planet Center officially confirmed V1 Borisov's interstellar nature on November 5th, assigning it the C designation used for comets. Yet even that classification felt like a compromise, a bureaucratic convenience, rather than a scientific truth. Yes, its orbit is comet-like. Yes, it came from interstellar space. But calling it a comet feels increasingly like forcing a square peg into a round hole simply because it's roughly the same size. Semantics matter in astronomy. Categories exist for reasons. And V1 Borisov was already breaking those categories before most people even knew it existed. So here we are, with two interstellar visitors, both refusing to act like the comets we've studied for centuries, both travelling along suspiciously similar pathways, both appearing within 13 months of each other. And we're just getting started, because in 3 days, something even stranger is about to unfold, something that will force astronomers to question whether coincidences this exact can exist in nature, or whether we're witnessing something that demands a far larger explanation. Let's talk about Gennady Borisov for a moment, because his story is nearly as improbable as the objects he keeps finding. He isn't some credentialed astrophysicist with an MIT PhD working at a world-class observatory. Borisov is a self-taught amateur astronomer who works at the Crimean Astrophysical Observatory, not as a researcher, but as an engineer. He built his telescope himself, grinding the mirrors by hand, calibrating the optics through trial and error. A level of dedication bordering on obsession. And somehow this man has achieved what billion-dollar sky surveys backed, by supercomputers and teams of PhDs. Yet somehow he discovered 2 interstellar objects using homemade equipment. Think about that probability for a moment. Since humanity began systematically cataloguing the sky, we've confirmed exactly 3 interstellar visitors. 1, One-Eye Oumuamua in 2017, 2, Two-Eye Borisov in 2019, and now 3-Eye Atlas in 2024. 3 objects in the entire recorded history of astronomy. And one man, one determined amateur, with a telescope he built in his backyard, found 2 of them. That isn't luck. That isn't random chance. That is 66.7% of all confirmed interstellar discoveries attributed to a single individual who technically isn't even a professional astronomer. When Borisov found 2-Eye Borisov on August 30th, 2019, the astronomy world was thrilled but not shocked. Oumuamua had already proven that interstellar objects existed and occasionally drifted through our neighbourhood. Finding a second one made statistical sense. Some models predicted we should detect roughly 1 per year if we watched carefully enough, and 2-Eye Borisov followed the rules. It had a beautiful textbook coma and tail. Spectroscopy detected water vapour, carbon monoxide, exactly the signatures expected from an icy comet. It was exotic because of its origin, sure, but it behaved normally. Scientists could categorise it, study it, write papers about it, without challenging fundamental physics. See 2025 V1 Borisov? Not so much. Dr. Karen Meach of the University of Hawaii's Institute for Astronomy led the observation campaign for 2-Eye Borisov back in 2019. She spent months analysing every photon of reflected light, creating the most detailed dataset ever gathered for an interstellar visitor. When Scientific American asked her about V1 Borisov's lack of activity, she didn't hold back. If someone showed me these observation frames without context, I would have classified this as an asteroid, not a comet. The orbital dynamics say interstellar, the photometry says dead rock. Those 2 statements should not coexist, and yet they do. She paused during that interview and added something that never made it to print, but circulated among colleagues. It's like the universe is demonstrating that everything we learned from 2-Eye Borisov might be the exception, not the rule. Now we get to the mathematically disturbing part. NASA's Jet Propulsion Laboratory operates continuous sky surveys built specifically to detect near-Earth objects and potential hazards. Their system processes about 150 million observations every year, flagging anything with unusual trajectories for human analysis. Statistical models predict we should find 1 interstellar object roughly every 1.3 years on average, accounting for sky coverage and observational bias. And those predictions have held up fairly well. Oumuamua in 2017, 2-Eye Borisov in 2019, 3-Eye Atlas in 2024. Spacing that lines up reasonably with expectations. But here's the kicker. The probability that a single individual would discover multiple interstellar objects before global survey networks do. Dr. Alan Jackson, a planetary scientist at Tailless University specialising in orbital dynamics, calculated those odds for a research paper currently in peer review. His number, 1 in 4.7 billion. For comparison, your lifetime chance of being struck by lightning is about 1 in 5,300. You are 3,700 times more likely to get hit by lightning than to be the amateur astronomer who discovers 2 interstellar objects. And yet Borisov did it. Twice. Some astronomers half joke that we should simply grant Gennady Borisov permanent naming rights for all future interstellar visitors, since he seems to have some kind of cosmic radar nobody else has. But the jokes hide a real puzzle. Why does his small setup succeed where massive survey systems fail? His telescope's aperture is 0.65 metres, respectable for an amateur, but tiny compared to professional instruments. Hawaii's Pan-STARRS telescope uses a 1.8 metre mirror and scans the full visible sky every few nights. The Zwicky Transient Facility in California images 400 square degrees of sky per hour. By sheer coverage alone, they should be finding interstellar visitors first. Every single time. One possible answer lies in method. Borisov doesn't scan randomly. He targets specific sky regions where calculations suggest incoming interstellar objects would be most visible based on likely approach vectors. He's essentially performing expert-level, educated guesses, focusing his limited, observing time on high probability zones that large surveys may sweep past, less frequently. It's the difference between casting a giant net into random waters versus dropping your line exactly where you know the fish migrate. Both strategies work, but one requires far less equipment if you know what you're doing. There's also the human factor. Automated surveys rely on algorithms to flag anomalies. But those algorithms have biases built into them. They're tuned to detect certain classes of objects: Earth crossers, potential hazards, bodies with predictable behaviours. Interstellar visitors, by definition, are unpredictable. They show up where they shouldn't. They move in directions that look wrong. Their brightness changes don't match any template. A human observer like Borisov, staring at the same slice of sky, night after night, develops an intuition for what normal looks like. When something deviates from that internal baseline, he investigates, even if the software wouldn't consider it interesting. But let's address the elephant in the observatory. Is there something connecting these discoveries beyond Borisov's skill? When V1 Borisov was discovered in 2019, its trajectory backtracked to an origin near the star Kruger 60, a binary system about 13 light-years away. Astronomers spent months confirming that origin, running simulations, publishing papers, feeling confident they knew where that visitor came from. Now we have V1 Borisov, and preliminary trajectory analysis suggests, well, no one is willing to say anything definitive yet. But the orbital elements do not point toward Kruger 60. They point toward a completely different region of space. So these aren't siblings from the same stellar nursery. They're strangers who just happen to look identical, behave identically, and arrive at the same cosmic party one after another. Can we talk about how bizarre that is? Imagine you're at a coffee shop and someone walks in wearing the exact same unusual outfit as you. Same obscure band t-shirt, same rare vintage jacket, same custom sneakers. Unlikely, but not impossible. Now imagine it happens again the next week, with a completely different person. Now you're entering what are the odds territory. Now imagine both strangers also move like you, order the same weird drink combination you always get, and sit in the exact seat you normally choose. At what point do you stop calling it coincidence and start asking larger questions? That's where astronomy finds itself right now with V1 Borisov, one tailless interstellar visitor acting strangely. Interesting. Two tailless interstellar visitors on suspiciously similar trajectories, discovered just 13 months apart, both refusing to behave like comets despite having cometary orbits. That's a pattern screaming for explanation. Dr. Daryl Seligman of Cornell University, who has spent years trying to explain Oumuamua's odd acceleration, phrased it perfectly in a November 7th Twitter thread. Scientific training teaches us to prefer simple explanations. Occam's razor, right? But sometimes the universe hands you data that makes all the simple explanations look ridiculous. V1 Borisov plus 3i Atlas and cry one of those times. We need new tools, new models, or maybe just new humility about how much we don't know. His thread got 47,000 retweets. Clearly people are paying attention, and they should be, because in 3 days, on November 6th, something is going to happen that transforms this from a scientific curiosity into a viral phenomenon that escapes astronomy circles and explodes into mainstream awareness. 3 objects. 2 constellations. 1 geometric alignment that should not exist in a random universe. November 6th, 2025. If you're using Stellarium, the free planetarium software beloved by half the amateur astronomy world, you can recreate precisely what happened that morning. Set your location anywhere in the northern hemisphere. Set the time to 6:10 a.m. local. Turn off atmosphere rendering so the distracting blue haze disappears. Then look toward the eastern horizon, just before sunrise. There they are, 3 objects forming a triangle across 2 constellations that have captivated human imagination for millennia: Virgo and Leo, the Virgin and the Lion. And positioned at the vertices of this cosmic geometry are 3i Atlas, C2025 V1 Borisov, and C2025 K1 Atlas. From Earth's perspective, they're close, really close, Not physically near, space doesn't work that way, and the objects are separated by tens of millions of miles in true 3D space. But projected onto the 2D canvas of the sky, they form a configuration so tight you could cover all three with your thumb held at arm's length. Astronomers call this angular separation, measured in degrees and arc minutes. The triangle formed by these three objects spans about 15 degrees, roughly the width of your fist held at arm's length. Here's what makes this arrangement break people's brains. It's not just close, it's geometrically precise. The triangle they form is almost perfectly isosceles, with two sides measuring about 8.3 degrees, and the third coming in at 7.9 degrees. That 0.4 degree difference is so small, it's nearly invisible to the naked eye. For perspective, the full moon spans roughly 0.5 degrees. We're talking about a geometric deviation smaller than the moon's apparent width, in a sky containing hundreds of billions of potential positions these objects could occupy. And yet they occupy ones that form an almost flawless triangle. Dr. Phil Platt, the astronomer behind the Bad Astronomy blog, and someone who has built an entire career dismantling cosmic misinformation, shared his reaction on Blue Sky at 7:23 a.m. that same morning. Okay, I just plotted the positions myself because I didn't believe the screenshots circulating online. It's real. The triangle is real. And before anyone asks, yes, this is probably coincidence. Probably. Maybe. Look, I'm a skeptic by training, but I'm also honest enough to admit this makes my skin crawl a little. His post gathered 8,900 likes in 6 hours. When a professional skeptic publicly acknowledges the strangeness of something, people notice. But there's still a fourth participant in this celestial arrangement we haven't addressed yet. C25 K1 Atlas, the object that completes the triangle. And K1 Atlas might actually be the strangest member of the entire group, which is impressive considering the competition. First identified on May 23, 2025 by the Atlas survey in Hawaii, the same automated system that found 3i Atlas, K1 Atlas quickly became a favourite among astrophotographers for one stunning reason. It glows gold, not the common blue-white seen in most comets, not the occasional green tint produced by diatomic carbon. Gold like molten metal, like a drop of shimmering sunset preserved in space, like something painted rather than occurring naturally. This coloration comes from an unusually high abundance of sodium in its coma. When ultraviolet light from the sun strikes sodium atoms, they emit a golden yellow wavelength at 589 nanometers. Most comets contain some sodium, but K1 Atlas contains so much that it dominates the entire visible spectrum. Images from the Isaac Newton telescope in the Canary Islands show it blazing like a miniature golden lantern against the stars, its tail trailing behind it, like a ribbon of frozen amber. So imagine the scene on November 6th. 3i Atlas in Virgo, dark and tailless like a cosmic cipher. V1 Borisov, also in Virgo, equally silent and enigmatic. And K1 Atlas in Leo, gleaming with its improbable golden light. 3 objects, 3 radically different appearances, arranged in a geometric configuration that feels intentional rather than incidental. The astronomy subreddit erupted. Astronomy Twitter became practically unusable for research because every third post was a simulation, a screenshot, or a theory about what this alignment meant. The configuration tightened even further on November 8th. Using NASA's Horizons ephemeris, the most precise positional system for solar system bodies, you can see exactly what occurred at 11:47 UT on November 8th. The 3 objects reached near collinearity from Earth's line of sight. Picture a ruler drawn across the sky. 3i Atlas, V1 Borisov, and K1 Atlas all fell along that imaginary line within 0.3 degree of perfect alignment. They formed what astronomers call a syzygy, a term normally reserved for eclipse alignments involving the Sun, Earth and Moon. But this syzygy consisted of 3 visiting objects, 2 confirmed interstellar, 1 still under debate, lining up across billions of miles of space. And here's the question everyone began asking. What are the odds? Dr. Jonathan McDowell from the Harvard-Smithsonian Center for Astrophysics actually ran the numbers. He published his methodology and findings on the astronomy preprint server, ArXiv, on November 9th, factoring in the total number of observable positions in the sky 41,253 square degrees for the full celestial sphere. The motions and current trajectories of all three bodies, and the narrow time window during which the alignment occurred. His estimated probability for this specific geometric arrangement occurring by chance, roughly 1 in 1.7 million. Those odds seem astonishing until you remember how many celestial configurations happen constantly. With thousands of known objects shifting across the sky, some coincidences are unavoidable. McDowell's paper carefully stated that while visually striking, this alignment does not demand extraordinary explanations. Yet when combined with the unusual physical behaviour of 3I Atlas and V1 Borisov, it deserves continued close observation. Translated from scientific caution, this is unusual. We don't know what to make of it, but we're definitely paying attention. Amateur astronomers express no such restraint. Online communities filled with observers posting their own images of the triangle. Someone created an animated GIF tracking the object's positions from November 5th to November 10th, showing the triangle form, tighten and slowly dissolve as they drifted apart. The animation went viral on TikTok, of all platforms, drawing 43 million views, with comments ranging from "This is beautiful" to "We're being watched" to "Someone please explain the math before I lose it." But what truly captured the public imagination was the symbolism. Virgo and Leo aren't random constellations. They're two of the 13 zodiac constellations that have held cultural weight for millennia. Virgo tied to harvest, purity, and cosmic order. Leo symbolizing power, courage, and solar majesty. And now, in November 2025, these ancient celestial patterns host three enigmatic visitors arranged in near-perfect geometry. It feels less like coincidence and more like a script crafted for maximum archetypal impact, except this script is unfolding in the actual sky, space operating under real physics. Dr. Frank Marcus, senior planetary astronomer at the SETI Institute, posted a thread on X attempting to frame the cultural reaction. Humans are pattern recognition engines. We evolved to see faces in clouds, hear meaning in static, and find structure in randomness. This alignment sets off every one of those deep neurological circuits. That doesn't make it supernatural, but it does make it unforgettable. And maybe that's fine. Maybe wonder is the correct response, even if the explanation ends up being nothing more than improbable statistics. His thread included this perfect aside. Also, can we address how K1 Atlas is literally gold? Universe, you're not helping the "this is random" argument here. He's not wrong. If someone wanted to design a scenario engineered to seize maximum public attention, they couldn't have staged it better. Two silent tailless visitors, travelling parallel paths, plus a brilliant golden anomaly, all gathering in mythically loaded constellations at the exact moment humanity has the capability to notice. It's borderline theatrical, but the alignment was only the opening scene, because as these three objects progressed along their solar paths, another force was about to enter, one capable of reshaping everything we thought we understood about these visitors. The sun was stirring, and it was furious. November 16th, 2025. Mark that down. Circle it. Set alerts. Engrave it into your astronomy-obsessed heart, because that's when C-2025 V1 Borisov reaches perihelion, the closest point in its orbit to the Sun. For any comet, perihelion is Judgment Day. It's the cosmic pressure test where ice meets furnace, where the object finally reveals its internal truth. Approach the Sun. Get blasted with energy equivalent to standing before the open core of a nuclear reactor, and demonstrate your physics. Most comets behave predictably. They heat up, volatiles erupt, tails burst into existence in dramatic plumes of gas and dust. It's dependable physics, the expected response. V1 Borisov sits at 0.76 AU from the Sun right now, around 70 million miles, roughly 3/4 the Earth-Sun distance. At this range, the surface of a typical comet would surpass 200 km. Water ice doesn't melt at that temperature. It flash vaporizes, expanding explosively from solid to gas. Carbon monoxide sublimates. Methane escapes. The surface becomes a battleground of extreme thermodynamic forces. And yet, observation after observation shows V1 Borisov maintaining the same stubbornly